Deep in the heart of our galaxy lies a dark secret. A monstrous, gigantic, supermassive black hole lurks. This supermassive black hole, aka Sagittarius A, is so gigantic in fact that it is 4 million times the mass of our Sun. Thankfully for us, this monster is located 26,000 light years away in the constellation Sagittarius.
You may be thinking, so what exactly is a black hole? How is it formed, and what is inside of one? Well, some of those are tough questions that astronomers and scientists don't even know the exact answers to yet. Hi, I'm Sky Hargrove, and I'll do my best to explain the secrets of black holes in this video. So what exactly is a black hole? A black hole used to be defined as a region of space so dense that not even light could escape it. However, according to new research, this definition may be a little off, which I will explain why later.
The name black hole was first created by Dr. Johnny Wheeler. This name holds some truth as light and other objects are pulled by the gravitational force of a black hole. And it is called black because we cannot see it, so technically it is invisible. We can only see how objects like stars, gases, and Legos behave when they get close enough to a black hole.
Now that we know what a black hole is, let's talk about how it's formed. A black hole is created by the death of a star. To understand this, we need to know how a star is formed.
A star starts out as a bunch of leftover cold molecular helium and hydrogen clouds that weren't swept up in the beginning of the universe, kind of like dust bunnies. As these gases continue to collect more matter and tug at each other with their gravitational pull, the now massive cloud, or the universal dust bunny, begins a nuclear reaction called nuclear fission. This happens when the pressure of the star material becomes so high that the nuclei go fast enough to start bumping into one another. When this happens, nuclei fuse together, and then the core of the star is where the most active gas is, making it the hottest part of the star. This gas moves so quickly that it becomes plasma. The star continues the cycle of pushing and pulling the plasma to the center for millions of years, until the star's nuclear fuel tank runs out of gas. When this happens, the reaction quickly stops, and the plasma collapses in on itself. Now what happens next is all up to the mass of the star. In the case of a black hole being created, the bigger the better. If a star is about 25 to 40 times the mass of our Sun, the star collapses into a supernova, pulling the matter of the star inward in a process called fallback. When this happens, ta-da! A black hole is formed. Okay, so we covered how a black hole is made and what it is. Now for the fun part. What is inside? Well, we really don't know until someone were to be pulled into one. Any volunteers? Like most aspects of science, we can only take an educated guess. According to the super smart scientist Albert Einstein's theory of general relativity, a black hole contains something called an event horizon and a singularity. An event horizon is the place of no return. Once you cross it, you'll be lost forever. After you do cross the event horizon, you'll go through spaghettification, or you get stretched like a noodle into the singularity, where you'll be crushed up and forgotten about. The problem with this is that it does not follow quantum mechanics. Quantum mechanics say that information cannot just be crushed up and destroyed. So, Joseph Polchinski has something to say about that. Joseph Polchinski, on the other hand, states that there is a firewall, a wall of quickly moving molecules that are created when particles are separated from each other, but still maintain a correlation. Through this correlation is the information about what makes up a black hole, thus agreeing with quantum mechanics, but not Einstein's general theory of relativity. So in comes Stephen Hawking. Dun, 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 dun. Instead of becoming a noodle or turning into a crisp, you go through an apparent horizon. An apparent horizon sucks in the matter through the black hole's gravitational pull, thus upholding Einstein's general theory of relativity, but then, instead of devouring the matter, it spits it back out. So, you still have the information about the black hole.
Whatever exactly happens in a black hole is still being debated by scientists, but hopefully in the near future we will discover the many mysteries of our miraculous and incredible universe.